You'll understand what I mean in a second. It's not like, I got advice on where to hide a body or something. That's like in the first 10 seconds of the recording, by the way. Um, but here's an example of using your computer science skill set to do something kind of cool. So how many of you are familiar with the Boodlebox thing we just got? How many of you have used the Boodlebox? You're late. Starts at 8:05.
I've been here. I just looked outside.
You have your bag just came in with you. By the way, did Ben think that he had told me you guys were coming over last night?
Yeah.
Oh, all right. Well, I'll talk to him. It's fine. Because I was at the neighbors for dinner and my wife's like, "Did you know they were coming over?" I have students doing labor in my basement, also on recording. They are being compensated.
Labor the code word.
They're being compensated. It's theoretically at this point. So anyways, and actually I told Logan about this, but I sent you the JSON output, right? That you saw that working. All right, so we have Boodlebox. Now at first I was very against Boodlebox. Not so much against it, but I didn't think it was anything special. So I was on the AI committee that helped select this thing. And now the positives of Boodlebox, which is cool for us, is that now as faculty, staff, students at Concordia, we have access to either the highest tier model from all the big boys or right below it. Like for instance, it's weird that we only have access to ChatGPT 5.1 instead of 5.2. But they always tell us, oh, we'll add things as they come out. And it took them a while to get Gemini 3.0 on there, 3.0 Pro, but it's on there now. So presumably ChatGPT 5.2 is soon. But it gives us access to the plus version from your guys' perspective of ChatGPT, the pro version of Gemini. So that's already, we're at $40 a month spend. And the pro version of Claude 4.5 Opus, which is expensive. Claude is the most expensive of the three big boy models. It does not have support of Grok right now, but I think they're getting it. But regardless of that, I'll tell you what, Grok is amazing at animations. If any of you have been to my Quantum Disciple website, all of those animations with Mr. Gonzalez in it are all done with Grok. Yeah, by my designer. I mean, I think she has crazy prompts and example images and stuff she uploads with it, but it's been pretty cool. But in any case, so now there's one interesting thing that Boodlebox can do that you don't get from having a subscription to ChatGPT and a subscription to Claude and a subscription to Gemini, and that's within the same chat, you can switch models. So you can say, oh, I want this prompt processed with ChatGPT. I want this prompt. The very next prompt, which uses the output of the previous prompt, I want that done with Claude, so on and so forth. That's kind of a cool thing. Now, the reason why it's a little bit slower than if you're using ChatGPT and those guys directly is because it's actually making API calls to their backend, as if, like, as computer scientists, if we wrote software that had the API key for talking to ChatGPT and talking to the different ones, and then we're paying for those per call, per API calls. Now, as computer scientists, we get to wield a programming language, right? And that programming language can then allow us to do some stuff that maybe the average user could not do. So, for example, if you are going to write your own program that talks to something like ChatGPT, and when we move on to the Pokemon thing where we're going to be talking to a free fake API, well, not a fake API, but a free API, that skill set isn't going to be any different than talking to ChatGPT's API or Claude's API. They all are communicating with JSON back and forth. So any of those things is completely possible for us to write code to do after you've learned this simple Pokemon thing here in class. So you'll have that background to do it. But you are paying per million tokens for that. So I have several businesses that run off of, for example, OpenAI's API, and I rack up $1,000 a month in API calls. Now, this is across businesses that are making money and stuff like that, so that's just the cost of doing business, but it costs money. Now, I'm not encouraging you to do this for, consumer or commercial products or anything like that, but from a single user's use case. What I did, so you have Boodlebox. So I have a program that opens up Boodlebox in a website. And this program controls the Boodlebox website. So I made sure I taught it how to click the button to switch things and to feed it prompts and to click the little copy button when the prompt comes back, all that stuff. And then what I did is, so my program that sits in front of that talks to Boodlebox, so if we drew a picture of this thing, let's get Keynote open. And this just gives you an idea of the things you can do from like an automation perspective and things like that. So let me just hide this. All right, so right here, we have Boodlebox. Boodlebox website. All right. Now, when you, so kind of the first big large language model was ChatGPT, right? So they were the leader into this world, and everybody else was catching up. And now we have like legit competition. We're rewatching iOS versus Android, except it's ChatGPT versus Google Gemini versus Claude versus maybe Grok, something like that. So we have a four-way competition instead of a two-way competition, which just benefits us as users, because these models will just keep getting better and better and try to one up each other, that kind of stuff. But I have this Boodlebox website that I can go and use by hand, no problem. And it's already a neat thing that I can switch between models. So I've already found value in it that I didn't give it credit for initially. Because initially I'm like, hey, I'm already using ChatGPT Plus. I'm already using Gemini Pro, not having any problems with these things. I use Gemini when I want to do certain things. I use ChatGPT when I want to do something else that's a little bit better at. I just don't use Claude, whatever. So, but I started messing with it. Now, first of all, Boodlebox's memory is much longer, and it allows you to keep like a knowledge base of a whole bunch of like interesting things that you want your chats to take into consideration. So there's a lot of stuff it does that the large language models don't. And as soon as you walked in, I realized I forgot to reply to your email. Do you have time for Zoom today? I can do we'll figure it out, but if you need to get it, it's due tomorrow, right? Oh, I apologize. It fell off my radar. As soon as you walked in, my heart fell. So I do apologize. But in any case, so it has a much longer memory. It allows you to switch between models if that's important to you. There's only going to be certain applications that's important. But when you talk to ChatGPT, for example, if you're using their API model, talking JSON back and forth, just like what we're doing here, they have created a standard of endpoints that you can talk to communicate. It's called their completions API. So what ended up happening is all the other guys have a very similar compatibility layer for talking to them. So it's basically the same completions API. They behave identically, at least largely. So there's some minimal amount. This kind of goes back to when we talked about interfaces last semester. So all of these guys decided to adopt as a standard the ChatGPT API endpoints. So they all speak the kind of the same lingo. Okay, that way it's convenient for programmers like us to just put in, basically have a single set of code and swap out the brain. Like I want to use GPT 5.2 now, Or now I want to use Claude 4.5 Opus, whatever it is, but we don't have to change the rest of our code because there's already third-party applications that know how to talk to large language models, and they were written with the ChatGPT standard in mind. But now you just can swap out and talk to Google Gemini or talk to whoever, and then you got to give them the new API key, but you're paying a different person. So what I did is I built Litman API compatible with OpenAI, which is ChatGPT. So this is that compatibility layer. So I have a piece of software that when this launches, it launches this website. All right. And here, let's make this a different color. All right. So this guy is now, he's a server. He's sitting listening for endpoints. So if I have a program that calls upon this server, passing it a request for a certain model, so like when you talk to ChatGPT, but we even just stay in that world, ChatGPT has several models available to you. You can say, I want ChatGPT 5.2, or I want ChatGPT 5 mini, or 5 nano. So that same syntax allows you to request different models. So I support the same thing, except I support ChatGPT 5.1, Claude 4.5 Opus, and Gemini 3.0 Pro. So when you make API calls to my front end here, it then controls the Boodlebox website, makes the request on the website for the model that you picked with your message, waits for the response, copies it, sends it back over the program to whoever called it. So now you can write your own software that uses ChatGPT, Claude, or Google Gemini, their top tier paid models, for free with your programs. That's kind of a cool thing for an educational learning thing. Now, you wouldn't want this as the back end of a major application with more than one user. And given the speed of it, I might even say more than 0.75 users, because it is a little more sluggish, right? But it is free. Well, we're not paying the bill. Your tuition dollars are paying the bill, I suppose. But just kind of a neat thing that you can do as computer scientists with a programming background is you can go and say, oh, well, I have a website here. I'm going to control this website. That's kind of a cool thing to do just as from the get-go, right? Sometimes you have websites that, you might have to click on 4 or 5 things and it's just kind of busy work and you're doing a whole bunch of those in a row. And if you can write an automation tool to do that for you, that saves you lots and lots and lots of time. And this existed before these large language models. So now if you could use that same tool where your broadsword that you're wielding with your programming language turns into a lightsaber, that's kind of a cool thing. So it's actually, so then really where this idea came from, how many of you have been following a project called OpenClaw? Originally, it was called ClawdBot, CLAWD bot. It's open source. I encourage you to check it out, but do not hook it up to a paid backend. It uses way more money than you expect it to. But in any case, so what ClawdBot is, and you can download it for free, it's really a neat tool, is it runs on your computer. So it's a running program that runs on your computer, and it connects into one of your instant messengers that you choose. And what it lets you do then is, so you give it a name, it allows you to chat with your bot that's running on your computer. And you select the brain of your bot. So if you want to play around with this and you want to keep it dirt cheap, use ChatGPT 5 mini. 5 mini I used for hours and hours and hours, and I've ran up like a 30-cent bill. It's that. But I was using some more powerful models at first, and I ran up like $100 bill, doing shockingly little, to be honest. But so anyways, this is something, so you can, from anywhere, you could text your bot that's sitting on your running computer and he'll just go do stuff for you. And he just figures it out. You say, go to this website and whatever. And you just ask him questions. He just goes and does it for you. He'll write full software applications or whatever. And he's only going to be as good as his brain. But, I'm thinking, okay, well, this thing's pretty expensive to hook to a back end, but I still want to mess around with this thing because I think this is going to be the future. You think about your computers today, we have, if you're on Windows, you have Copilot kind of built into it, but Copilot doesn't seem to be all that useful. Is that a reasonably correct statement? But it feels like maybe eventually. But if you could talk to your computer and instead of just asking Copilot, what's the weather like today or something like that, you could tell it to like do all this stuff that you wanted to, like, let's say you're running a business and you have 5 steps that you do every single time someone makes a payment for their rent or something like that. It's going to go and update this spreadsheet and send in a thank you email, receipt, yada, 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 all these different steps. You could just text it saying, Bob paid me $1,000, record it. And your bot just goes and does the crap for you. That's kind of, it feels like it's the future of computing. I don't think it's quite there yet, but I thought, wouldn't it be cool since it's behaved the best under one of the stronger brains like ChatGPT 5.2 or Gemini 3. They recommend Claude 4.5 Opus, but I don't use their API. But now I can because I wrote my own API that I'm connecting up as the back end to ClaudeBot so that it can run. Some of the API runs on my computer. The bot talks to this local API, which runs the Poodlebox website and gives me the results back for all the different OpenAI responses. Just kind of a cool thing to mess around with. Definitely sluggish. Yeah, it's slow, but if a lot of these things are just happening while you're sleeping at night, who cares? It takes 4 hours to do something that used to take you 25 minutes, but you're asleep while it's happening. That's 25 minutes you saved. Who cares how hard your computer worked? So anyways, just something kind of interesting that I messed with this weekend that was just kind of like, oh, this is actually working. How does it? I don't know. I thought it was neat. Okay, so let's get back into any questions about any of that before I dive in? Because we're going to be talking to an API here shortly. Okay, so at the end of last class, we had a bug in our code, and actually it wasn't a bug in the code that we've written. I put a comment next to it down here. So in our get object that we wrote a while ago, this guy was never actually setting the string that we were reading because we decided to go and write the get array part of it without ever coming back and finishing this part. So we were just missing one line back in get object. It wasn't a problem with our get array. Let me comment out a couple of lines here real quick just to show this. And then what I'm going to do is I'm actually going to slowly transition to something else. Let's see. All right, so here's our call to our my first JSON parser.parse that we know we wrote to kind of only go down one depth level, just to kind of see how this parsing works. So this is going to give us all of our strings from this guy. So it looks like that. All right, so this is the array that we outputted from it. So here's my first JSON parser.parse. So we came in here to our parse function, this guy right here, which takes in the JSON string, trims it, and then just calls our get object to get the ball rolling. And then from there, those objects make the recursive calls to get the next guy. If I have a new object, what do? I call get object. If I have an array, what do? I call get array, so on and so forth. So there's not a reason why this can't go down various depths, but because we're only returning strings right now, it becomes problematic for us to write more here. And I only want to spend so much time on our parser since I think we get the idea of how a parser might work. This is one of those things that we know we can throw enough hours at and make it solid. But you know, eventually we imagine there are tools out there that already do this job for us. And we're going to look at that um, uh, here in a few minutes. But what I want to do is at least get us across the line of how might we use something like this. All right, so I have now taken our cruise ships.json. So our API gave us this wall of JSON. We now need to turn this into something usable in our program. The whole reason it's in JSON is JSON holds metadata. So it doesn't just hold our data like in a comma separated list like we had originally looked for a CSV file, comma separated values. It now holds it with name value pairs. It gives meaning to our values. So this is an upgrade. This is kind of storing things in object format. Now, we originally had created this class called cruise ship. Now, remember when we originally had our cruise ship, we were parsing on a comma delimited thing here, right? Okay. Well, now we know we are getting something that looks like this. So we have ship name, we have gross tonnage, we have max passengers. So it's still comma delimited because of the way our string is pulling it out, but we extracted it from a JSON document, giving us a whole bunch of name value pairs that are separated by commas. Now, keep in mind, this doesn't bypass our original problem of CSV files where I said, well, technically your divider can't exist in this guy. You know, since we're splitting on a comma, our data can't have a comma in it. That's still the case for us now, but it won't be the case here in a couple of minutes when we move to a already done JSON parser that gives it to us in objects. And we'll look at that. But just for the moment here, we know that we get strings that look like this. So if I go ahead and I put this string up here just as a kind of a remembrance type thing, and then we decide, okay, well, if I'm going to build a cruise ship out of that, a string that looks like that, I can create a constructor that takes a string and goes ahead and processes that guy. All right. So we extracted this from our JSON. We're going to go in here. We're going to split on commas like we did before. So that gets us our parts. But now within each of those parts, we have something that looks like this. We have our ship name. We have our gross tonnage. We have our max passengers, but we have no guarantee of what order these are in necessarily. All right. So we're going to have to look at those name value pairs to decide which value am I setting. So the parts has 1, 2, 3 elements in it. All right. She's still not awake. You could totally tell. Yeah. Your eyes were already closed when you walked in the door. You're a half hour late. What's up? See, I told you, she was still asleep. All right. So anyways, we're going to have, so the parts is an array holding 3 elements. We good with that? So now as we go through that array, I think I had done this one other time, but I'll do it again here. I showed you a for each loop in Java. So we're going to do for string s, and in Python, you would have said in Java, you put a colon. So for string s in the parts. So that's going to take you through the parts array. Now, for each of those guys, we want to split this on a semicolon or a colon. So now I need to say string array, we can call it temp, is equal to s, which is the current string from our array of parts. So the first time through this loop, this would be the parts at bucket 0, then the parts at bucket 1, then the parts at bucket 2. So a for each loop that we're running here is not better than a normal for loop. It just solves a problem maybe more conveniently for certain things. So in this case, we don't really care if the thing's at bucket 0, bucket 1, bucket 2. We're not going to need the access to that index. The index isn't important to us for what we're doing here. We just know that I have a string and I need to do something with it. So in this case, it's more convenient for us to just say, give me all the individual strings that are in that collection, rather than me having to say, give me the string that lives at bucket 0, then give me the string that lives at bucket 1, when that bucket 0, bucket 1, bucket 2 thing aren't important values to us. All right, so we lose our ability of knowing where we are in the array, but we get the convenience of already having the string, rather than having a number that we can use to go get the string. So we'll say temp is s dot split. Now, I mean, if we want to be extra, we've been doing trim, we can go ahead and do that. It's not going to hurt anything. So that just removes the white space off either end. So we'll say s dot trim dot split, and we're splitting on the colon. So now that's going to fill up temp with some strings. Now we happen to know that the strings that are going to be in there are going to be one that's going to be ship name, colon, Carnival Glory. Another one, gross tonnage, colon, 110,000, yada, yada, yada. We know those are going to be our name value pairs. So when I split each one of these strings on that, I'm going to get bucket 0 is this guy. Bucket 1 is this guy. So I'm going to be checking bucket 0 for which value am I looking at here. So I make sure I set the correct field. So we're going to say if S at bucket, actually we want to do this. We want to deal with each thing. Actually, we know we're only dealing with one string. So we're going to say if temp at bucket 0, why can't I say, actually, I might be able to say this, but tell me why this might be problematic. If this guy says ship name, then we're going to say this dot ship name is equal to S at bucket 1. Why might that Boolean expression be problematic? Go ahead. Well, temp at index 0 will always be, if I'm splitting something that looks like that, and I'm splitting on a colon, temp at index 0 will always be ship name in this case. Well, Carnival Glory is going to be S at bucket 1. So when we split on a colon right there, bucket 0 will be ship name, bucket 1 will be Carnival Glory. Then when we move on to the next S, we'll be looking at this S, where bucket 0 will be gross tonnage, bucket 1 will be the 110,000 as a string. So we're always splitting on these guys when we're inside of this array. But why is a double equal sign possibly problematic here in Java? It is not problematic in, for example, Python. But many different languages have this nuance, and it's something that we want to be aware of. Good. Okay, so he said Java's strongly typed, which is true. I'm trying to decide just its strongly typedness have anything to do with this. Your second part is accurate. Um, well, so the double equal sign in most strongly typed languages, actually outside of Swift, because they just made this work. But the double equal sign in most strongly typed C-based languages compares primitive types. What were you going to say? Yeah, so you're saying the correct thing to do here is dot equals to make sure we're right. Okay. But if you remember back in coding 1, we did an experiment one day where I created like 3, 4, 5 strings. And I created several different statements where I said like, S1 equal S2. And one of my strings I created was like string S3 equals new string hello, where I actually use the new keyword. When we create strings like this, if I just say string R is equal to hello, R is, well, it's going to check this string literal here. And it's going to say, have we already stored a string that matches hello? If we have, we're not going to store it a second time. Instead, we'll just make R point to the same place in memory that we previously stored this string literal. Whereas if we say string R2 is equal to a new string hello, even though this is the same string literal, because we are explicitly asking for new memory, it won't even check Java's special literal space. It'll just say, you asked me for more memory, you get more memory. So it's going to go and create it. It'll have a different memory address behind the scenes. So the reason double equal sign is dangerous to use when comparing strings in languages like Java is because you don't know whether you're dealing with the first time of this literal or another time for this literal. So you don't know if my if statement is actually, your if statement is definitely not comparing the contents of these strings. So when you use a double equal sign here, you 100% are not checking to see if this string matches the identical contents of this string. That's probably what you meant, right? Usually when we say is one string equal to another string, we want to say, are they spelled the same? Do they use the same capitalizations? We're talking about what's inside of the string. Where really the double equal sign is saying, is this string, does this string and this string, do they share the same memory address? Are they equivalent at the memory address level? Not are their contents the same? Now, if they're equivalent at the memory address level, their contents would be the same. But if they're not equivalent at the memory address level and the contents happen to be the same, it's still going to return a false because they're not equal at the memory address level. We want to compare these guys based on contents. 99 times out of 100, probably even more often than that. When we're comparing strings, we want to know if they say the same thing. Okay, so unless you specifically want to compare strings on their memory address, we should never rely on the double equal sign in most programming languages to compare strings. Always go and double check. I can tell you that Python, the double equal sign, does compare the contents of those strings. That's a true statement. But you're going to want to confirm that with all of your programming languages to see how do they define the double equal sign for comparing strings. That's an important nuance of programming languages you want to keep in the back of your head, especially as often as we use strings, which is a lot. All right. Now, one might say, since Java is a string-based language, why did they just make the double equal sign work the way we want it to work? But I frankly think this is probably the better way for it to work. Double equal sign always, always, always works on primitive types, and pointers are a primitive type. So that makes it dependable as opposed to kind of what Python does is gives you kind of a convenience functionality for the double equal sign, which as a longtime programmer, you maybe say, okay, I appreciate that. I don't want to have to jump through 30 hoops to compare strings, but it's not an unreasonable approach. Go ahead. Well, I'm about to delete some stuff. No. Yeah, I was just recanting what I had done, a semester ago when we compared two strings that look the same. R equal R2 in this example is false. When we really probably want it to be true. Because hello and hello are the same string. But they're not actually the same string. They are two completely different strings that just happen to have the same content. But the double equal sign is not looking at content. All right, so what we should do down here, so I'll just dump this. So what we should do down here is say if temp at bucket 0 dot equals ship name dot equals. String class has two equals methods. One, the dot equals that we're using here. Actually, they have a couple of versions of the equals methods, but let's not burn more time with that. The version that we're looking at here that we probably want to compare strings to strings instead of a string to an object, which would compare it to its toString. Dot equals says we are comparing contents identically, taking case sensitivity into consideration. There is also a equals ignore case if you want to specifically compare this string and throw upper and lower case out the window. You can also accomplish that same thing in languages that don't have a ignore case, because pretty much every language has a function that will convert a string to upper or lower case. So just convert all your strings to lowercase, and now you're comparing with case insensitivity, right? Or convert them all to uppercase. Now you're comparing with case insensitivity. That's a tough word. All right. So really, if you're dealing with strings in most high-level languages, use the function that they gave you for comparing strings because you probably want to compare the contents. All right. So what we're going to say is we're going to split something that looks like this up on the colon. Keep in mind that this for loop gets us this entire, gets us this entire thing. And we are splitting on this, on a comma, which is going to give us an array where this is bucket 0, this is bucket 1, this is bucket 2. So each time through this for each loop, S will be equal to this guy the first time, this guy the second time, and this guy the third time. That's what we're dealing with. All right. So we'll go ahead and split on the colon for the string we have here. And we're going to say if the element at bucket 0 here, which will be that guy, the first thing, the thing that comes before the colon, if that guy is equal to ship name, which is one of our options. We are not guaranteed order here. So it's possible the very first thing we run into is max passengers, depending on who wrote the JSON. JSON does not guarantee us ordering. All right. Even if we wrote it a certain way, we're not guaranteed that. So we do need to process the JSON not considering order. So if we happen to be looking at ship name, then we're going to set the ship name. And what's the ship name? The ship name is going to be temp. This guy at bucket 1. So we're going to be setting the ship name to Carnival Glory in this case. Else if some programming languages will have something called elif, something like that, which is like a shortcut for else if. Just something to throw in the back of your head if you see that. So else if, I'm just going to steal that whole little line there. Else if we're looking at gross tonnage, then we want to say this dot gross tonnage equals, now we got to scroll up here. Notice that gross tonnage is an integer, but we are going to get it as a string. So if I know I'm looking at something that looks like this, but he's currently in string format, how do I take that string and juice the integer out of it? What tool do we have available to us in Java that allows us to take the string representation of a number and give us the integer representation of that number? Yeah, so you have one word right of like a whole bunch of it. Hey, you were close enough. I mean, for you, that was solid. I do equally attack everyone. So, okay. So in any case, we know we're dealing with a string. We are not doing error checking here. We had decided a while ago that we were going to focus on, we're going to assume our JSON's accurate. So we're not going to error check it, but we'll say, okay, if this is gross tonnage, I know I need to do integer.parseInt on whatever temp at bucket one is, because that guy's going to be the string representation of a number. All right. Now, we could say else here just because we know, but let's be explicit. So we know that the only other option, else if, we're dealing with max passengers. All right, so if we're dealing with max passengers, then we know that this dot max passengers is going to be equal to, and let's look at the type on max passengers, also an int. So we're going to use the same thing. So we're going to say integer dot parseInt. Oh, did I? Oh, thank you. So what you're saying is maybe don't rely on the completion thing, like I've told you, that helps you not misspell stuff. Is that what you're really getting at? It's like, Living's been bragging about this not misspelling stuff, and he's just throwing random variable names in there. Hey, all right. What he was saying is, I had this is I had the format like that when we used camel case for our this is camel case where you have uppercase letters in the middle, like the humps of a camel. All right, so this should set our three fields for this particular loop through this string. I I did right here. Oh, yeah, I get it. No, we don't. I was testing you. Finally, you totally redeemed yourself. All right. So now we are doing what we should do with that second value, not considering the order. We're checking. We're saying if I'm looking at ship name right now, I'm gonna just keep the second guy as a string. If I'm looking at gross tonnage, turn him into an int. If I'm looking at mass passengers, turn him into an int. But set the appropriate guys. We don't know what order this was given to us in. We just know that we have those three values. All right. So we are currently inside of the constructor for cruise ship. So this is going to take that string, and by the time this is done, we have set our three fields. So we can go ahead and dump that guy. And we could have thrown some trims in there, but let's not beat a dead horse at this point. All right, so now we have strings that can build our objects for us. And I think, did we give ourselves a, well, let's just use get ship name for it. All right, so now that we have those strings, when I go back out to driver, we are currently calling our parse. So our parse must be the guy who's going through our array. So if I go into my first JSON parser, I go to parse. This guy is calling get object. So we hand it off to here. Get object goes and does his thing. Where am I doing my elements of the array? Where I'm printing it. Oh, right here. Huh. Oh, yeah, thank you. So what she's talking about is in my constructor for cruise ship, the value that's coming in here is called S. So it would be bad form to call it S down there. I'm going to change this to be called the JSON. And then we'll split on the JSON. I think the rest of it should take care of itself. And this gives us a cleaner name for, this is what I expect you to pass in, a JSON string. All right. So right now we are printing out all of our things. I got to go see where that is printing out. So somewhere inside here, we are array right down here. So right down here is where we are. All right. Go away. All right, so right down here, we're spinning through. This is when we hit our opening square bracket. We know we have an array. We go ahead and call get array. This guy eventually spits us back out the array that we've collected. We then take that array, we just spin through and we spit out these strings. But now what we're going to do is we're going to take those strings and we're going to build objects out of them. So we're going to say cruise ship CS is equal to a new cruise ship, and we're going to pass it our string LOL. Then we're going to say cs.get, what is it called? Get ship name. Maybe like that. Get ship name, looks right. All right, so now rather than displaying the string directly for the entire string, we will build a cruise ship object, passing it the string representation of it that we extracted from the JSON, and then print out just the name of that cruise ship, but using the object to do that, to prove that we built our object. So we should just get a bunch of names of cruise ships now. All right. Oh, that seems kind of extra bad.
Is it because we already iterate through it one time?
Nope, that shouldn't make a difference. Where am I still getting my strings? I'm printing this out somewhere else. I have my array right here. We're reading it in. We're going through our strings. I'm not printing out LOL. Am I printing it out in the constructor? We come into our constructor, we do all our.
Well,
No, I mean, so this we're not printing anything here. So this is all fine by the time we get here. So we must be printing something in one of our places in here, maybe as we're getting our object from our array. Let's just do system dot out. That's my ship name, so that's the one we want to keep. That's commented. That's commented. We're printing out temp, as you said. So we'll at least get that out of the way, so we don't need to prove that we read that in. That one's okay. That one's okay. All right. So our expectation from this is that we're going to get a bunch of nulls now. Are we getting nothing back from that? Killing me. All right. Well, obviously I can go debug that, but instead of doing that for this moment, because we're moving away from this anyways, are there questions about this concept of building an instance of an object using a string representation that we extracted from something? It could be a JSON object that we call in something, or it could just be a string in a certain format. And based on that, we construct our object. This gives us an example of a use of constructors inside of classes. Their job is to construct objects. So realistically, I could have a second constructor, which is polymorphism, right? So I can say, well, I'm going to have another constructor for cruise ship. And this guy is going to take in a string ship name, a string, what is it, gross tonnage, and a string max passengers. I'm going to take in those pieces of information. I'll just set this dot ship name is equal to ship name. This dot gross tonnage is equal to gross tonnage. This dot max passengers is equal to max passengers. So we can build a cruise ship that way too. So we can have a class that has two separate constructors that take different inputs to work. This one takes in a string that presumably currently is equal to null. or at least what we spit out is equal to null. We can chase down the issue, but this constructor takes in a string and does what it needs to do that string. This other one takes in the 3 individual parts and does what it has to do. In either case, it constructs a cruise ship for us. Make some sense? All right. So rather than dive down this whole debugging what's probably just an if statement somewhere, I want to show you a alternative. So we have a already built JSON parser. And if you look in here, it's going to have a lot of stuff that we had already done. You know, this is a switch case instead of a bunch of if statements, but it's looking for opening curly braces, opening square brackets, the same kind of stuff. It gets into some other things that are kind of special cases in JSON that we didn't really fit perfect JSON in ours. But as we go through here, we should see that there is a lot of things that we've seen before. All right, but it's already built for us. We can assume it's working. We'll see. But we'll go out to driver. So instead of using our parser, which we can currently say is slightly problematic, even if we fix the current bug, it only allows us to go down 1 depth. All right, we can certainly throw more hours at it, get it working, but whatever. All right, so now what we're going to do is we're going to call this JSON parser, this guy right here. And this JSON parser, we are building using data, which is our string. So that's a JSON string. And then we're calling parse on it. All right, we can use our imagination that we know what a JSON object looks like. JSON objects look like this. And at the very, very, very top, we have an object, a JSON object. All right, so the thing that we're going to get out of this is a generic object. All right, so let's look at what that gives us, just that generic object that we built from there. Now, remember, I am printing out OBJ. And if I print out a object that's a generic object, what kind of output do I expect to get? Just a generic object. Get a memory address because it calls his toString, right? All right, so we should get a memory address, but we should be able to look at that memory address and find out what kind of thing is this guy. So we'll go ahead and print this out. It's just still my, oh, let me just get rid of that constructor and move on with life. All right. Oh, this is actually interesting. All right. So I am not getting a memory address. What does that tell us about this particular? Now, we read it out of there. So when we go into JSON parser and we look at parse, where's parse? This guy right here, we see he returns a generic object, okay? But a generic object, since everything inherits from the top level object, we can put a very specialized object and store it inside of object, right? A generic object. So an object is allowed to carry us. We could think of it as a one size fits all bag. So anything we put in there from the outside looks like an object, but in the inside, he's actually what he is. All right. And if we send, well, let me ask this question first before I give you the punchline. You expected there to be a memory address, and any reasonable person would have expected a memory address based on our knowledge of how generic objects work. A generic object, if you call his toString, you will get a memory addressy thing. We do not see a memory addressy thing here. We see a string representation of our JSON. What does that tell us about whatever object we're dealing with here? What does that tell us specifically about the toString method? If system.out.println for a generic object always calls the toString method, whatever object actually is living inside of this object, he must have written his own toString method. right? Because we're just saying object, call your toString, even though we know inside here is a much more specialized thing than a generic object. And that guy happened to override the toString method with his own more local toString method. So when we yelled into that bag and we said, hey, call your toString method, he said, no problem. You know, I'm basically a Harley Davidson stuck in this bag. My toString method does so much more than the generic memory address one. But you told me to call it, so I'll call it. So that's what we're viewing here. We're viewing the more specialized version of the toString method that came from whatever was put into that guy. But we're not going to stop with this guy here, because when we look at this, we're saying, oh, it looks like he read in our JSON. I already had that in the file. I could have had that without the 5-second delay that it went through, right? Go ahead.
So how did JSON parser that?
This guy, I just brought him with me. It's a third-party JSON parser.
I thought you included that.
No, there's a zillion JSON libraries out there that already are written in every single language. You can just go grab one. You could ask any of the AIs, just write me a JSON parser, put it inside of a single class or whatever, so you don't get this whole library of 30 different classes that it's sharing. Because we don't care how scary it is on the inside. You go to Home Depot and you buy some giant machine. You don't care what's inside that machine. You just want to plug it in, turn it on, and start sawing stuff. Right? So that's what we got. we got a dude. I can build him, throw him a string, and he just does what he does. And then it tells us the way to use this guy. And this will be a good introduction for us because this gets us into kind of Java dictionaries. So we get this object out of here, doesn't really matter to us. So what I'm going to do here, let's look at this next line. All right, so this next line, we're calling this class called map. Let's see, do I have map already open? I have to figure it out here, but yeah, I know. One of these tabs is using a ridiculous amount of battery. As you see these two guys right here, these two Chrome things, those are my multiple API servers running, holding the Chrome browser open on BoodleBox. So one of these tabs must be using that and just burning through my battery when I have the lid closed. So in any case, well, let's go to the map class here. So we have inside of Java something called map. Now, first of all, map is an interface, not a class, as a starting point. So that means when we create this, we are saying, I am going to map this. Well, map is the wrong word here. I'm going to create something that follows the rules of the map interface. So remember, interfaces just tell us how something must look. We do get a whole bunch of stuff down here. We have, okay, so a map interface says, I need key value pairs. Right? Does that sound like a dictionary to you from Python? Key value pairs? Okay. So that's what map is, but this is an interface in Java. He describes the concept of a class being able to store key value pairs and what must exist to treat that guy like a map. All right. And now it shows us a whole bunch of classes that have used map to implement their thing, but we won't dive into that. Let's just look at what map requires. So map has a clear function that will remove all the mappings from this map. If we want to dump our dictionary, it's going to have whatever this compute stuff is. We could ask it if it contains a certain key. We can ask it if it contains a certain value. Let's see, we can get the value given the key. We're starting to hit the normal I use dictionary stuff. You know, do you have this key? If so, give me the value from that key. All right, so we're reasonably okay with that. We can ask if it's empty. We can get the key set, which returns a list of all the keys. You can do the same thing in Python, blah, blah, blah. So we can put a key value pair into the thing. We can remove a key value pair, so on and so forth. We can replace one. So effectively, this map interface is Java's version of a Python dictionary, and it describes what all maps, all things that implement the map interface, what they must have. We don't care what's under the hood. If we know this thing is a map, we can use it as a dictionary just through these functions here that we know must exist. All right. So we'll go back to our, where's my, go back here. All right. So have I printed out the map yet? Let's get rid of object here and let's just print out. So map gives us our root thing here. So let's look at what this guy looks like. I don't know if he's overridden um, his toString. It looks like he has. So we really haven't gotten much better. So let's go ahead and explore this map a little bit. So what we're going to do, we saw that there's a bunch of functions this guy has. One of them is key set. So let's ask this map. Let's just ask him for his key set and print that out. Let's see what set is by default so we don't have to start mapping stuff. So we're just going to print out its key set, which should give me a set data type, which is a collection. Root dot, what was it, key set? That guy. So let's see what that looks like, what the default toString is for a set. All right, so we get something called ships at the top level. That's what that set looks like. That does match what we have at the very top level here. If we want to get the value from that object of ships, we can go back into map because ships is a key. The value of that is an array, right? So we saw maps down here. Has a get, returns the value to which the specified key is mapped, or null if it's not mapped to anything. So we will call get, well, I think I can remember the get part. Lost. All right, so we need to be in driver. So we have our key set. Actually, we don't even need the key set here. We're going to say root dot get, and we're going to say ships. And that should show us the value associated with the key that is ships, which should be a JSON array. All right. That is this guy. The value associated with ships is an array. All right, so there's my closing square bracket. There's my opening square bracket. So let's say we're fine. So that's an array. So now we have to look at how can we go through this array. So let's go back to map. So we can get the values of this guy contained in this map as a collection and then walk through that collection. I'm guessing we could probably also walk through the contents of map as well. Let's go ahead. Oh, we actually have a for each built into it. We know the key set is just at the top level is just that. We have an array. So let's get the values out of that into a collection. And let's do this as a, well, let's just see what it gives us. All right, so this will get us the value of that object, which we saw as an array. We're going to say, now give me the values. So dot values like that. Give me the values of this guy, which should be now a collection that we should be able to iterate through. Let's see what he looks like. You know, we're kind of jumping down the line to see, can we finally get the name of an object? Or is it just, have they all rewritten their toString to look friendly? So far, they all have rewritten it to look friendly. But this will give us our values, the elements inside of that guy. So it cannot find symbol. Was I... Dot values is right here, returns a collection. Should have been fine. Root.get ships.values. Oh, it's I have to it's an exception issue. Here, let me just do this. Throws exception. Let's see if that at least makes it go away. Nope. All right. This is telling us we need to there's unsafe operations here. Probably it deals with threads and collisions, things happening, or race conditions rather things happening at the same time. I'm not going to print out values. We'll just assume everything's fine. Let's see if I can at least put it into an object. So we'll go ahead and say collection of object. We'll say ships is equal to that collection probably lives in maybe java.util. Let's see if it yells at us. Yep, can't find symbol. Import java.util.collection. I think it lives in java.util. What's it? So a collection does not have, this map doesn't have values, is what it seems like. So it must not fully map to map. Because it tells me anything that is a map.
Is it because you're doing the dot value, not the get objects?
I don't think so. Because if we walk down the thing here, we have,
Well, what is
here's
that?
our root, which is our top level object. Dot get ships is our array. Dot values. Oh.
Because dot get is returning an array.
Yeah. So a collection is from arrays. This guy is an array, but what does get tell us he gives us? He gives us a JSON object. A JSON object. Let's start with this. Let me just try this. For object O in root.get value ships. So that's our array, right? And then let's do a system.out.println.
You're typing today.
I know. Println O. At least I haven't accidentally typed any swear words yet. Oh, was it just
I
get?
think it's just get.
Okay, so for each can't be applied to that. So this gives me an array. I know we had printed that guy out, does it? But it doesn't tell me. Let's ask him what class he is. System.out.println. It's probably going to tell me he's a, because all objects have class names. So if we go to this, we scroll all the way up, we go to, I'll just click on one of these classes. Get to our object. Here's what all objects have. Don't we have class name from this guy? Oh, is there a get class I missed? Oh, thank you. So let's see who he thinks he is. Otherwise, I'll write this this part out before next class. So we're not burning time on using third-party stuff. I just want us to get us past the JSON. Okay, so he's an array list. Good. So this guy tells me he's an array list, which means, do we get what kind of thing, what kind of array list he is? So we can say we have an array list. AL is equal to this guy. We don't necessarily know what he's an array list of, so this is going to be an array list of generic objects. And then we can say for object O in, I'm sorry, it's not in, it's AL system.out.println O. And that actually works out well because array lists were something we were about to talk about. No, it's java.util. This guy's an array list. Where's my get class? I still had it on here. All right, doesn't want me to convert to an array list. I'll mess with this. My guess is it maybe wants me to do this, but I'll get this all working before next class so we have an array of our things. We'll get it printing out real quick, and then we'll immediately go do the JSON we're getting from our Pokemon thing. And then we'll have an assignment over the weekend processing Pokemon, similar to what we've been trying to do here, but I'll do everything else with the third-party parser. We are going to chapel, front row, if you're interested. All right, here, we got a working version of the code. Here's my array list. I think we can process it now. So we're probably basically good to go at this point, but I'll get it completely functional before next class so we can just dive in. We'll talk about it for a few minutes and then go.